Okay, third one is mechanical advantage. Okay, mechanical advantage is the ratio of the force produced by a machine to the force applied to it. So machines are made to make our lives easier. So we're comparing the force I have to apply to the machine. Maybe it's a screwdriver, maybe it's another type of lever, maybe it's a pulley, wheel and axle, anything like that would be a machine. We want to compare the force I have to apply to it to the force that I get out of the machine. And hopefully the force applied isn't as much, otherwise the machine isn't very useful. So mathematically, the mechanical advantage is the output force divided by the input force. Okay, again, the output force we hope is bigger. Okay, if when we divide these, we get a number smaller than 1, then our machine doesn't work very well. Not very useful. We want a mechanical advantage of more than 1. Okay, so one option is the output force divided by the input force, or the input distance divided by the output distance. Now with most machines, usually we have to use less force, but we have to apply it over a greater distance. So if you think of a pulley, once we start adding more pulleys to a system, it makes it so we have to pull the rope harder, or excuse me, not harder, but longer, but we don't have to apply as much force. Okay, just like on a lever. Okay, if I let's take a ruler for example. If I have my pivot point clear down here, okay, I'm not going to have to apply as much force here, but look how much further I have to move that ruler compared to the distance here. So I've got to move it further, but I don't have to apply as much force. So our input distance is more than our output distance, but that's okay because our input force is going to be less. Okay, so here's an example. Your book has a problem. It says, find the mechanical advantage of a ramp that is 6 meters long and 1.5 meters tall. So this is using the distance, okay? The input distance, that's actually what we travel, or our input force. That's actually what we're applying. So mechanical advantage, okay, input distance divided by output distance. Our input distance was 6 meters. That's how long the ramp was. That ramp raised us 1.5 meters. That's our output distance. Okay, when I divide that, I get 4. Okay, again, I want a mechanical advantage of more than 1. Okay, usually if it's less than 1, I've probably got them upside down. I've done something wrong. Okay, there are machines that have a mechanical advantage of less than 1, but usually it's not the case. Okay, in the case of force, okay, if I had a screwdriver and I was applying 10 newtons of force, okay, but the output was 40 newtons, okay, I would have something like this. Output force was 40 newtons. Input force was only 10 newtons. Okay, that also gave me a mechanical advantage of 4. Now it's not always 4. And notice there's no units for mechanical advantage. It's just a number. Okay, the higher the number, the better the machine.